Hello again, everyone. So in this video, I'll be particularly discussing about the continuation from the chapter 7 straight line graphs, but in particular about how do we convert a nonlinear equation to a linear form. Why? So in that case, you have to kind of go back to the other video about the application, finding relationships from data. So you see later that how nonlinear equation must be transformed into linear form. Then we need to use it to solve the given problem. So in this case, I have this particular set of questions from textbook of Soup and Burton. So let's just talk about it. So convert each of these nonlinear equations into the form of y equals mx plus c. Notice that the y is capital and the x is also capital. That means the y capital here does not necessarily y small or the variable that we usually use. It means it can be the small y, it can be y squared, it can be ln y, it can be e raised y or other stuff. The same is true with the x. The x can be x squared or it can be ln x. Also, it can be 1 over x, it can be square root of x or anything. Bottom line, we want to convert these nonlinear equations so then they look like linear. So then whenever we sketch the graph, it will be linear. Why do we need such a thing? Right? That's so weird. Why do we need to do this? The thing is that the way I make sense of this is because in any way linear is always easy to analyze, right? Easy to analyze. So then even that the actual relationship is not linear, we can try to convert it to become a linear form. So then it's easy for us to analyze. Because people, like even common people, they don't study math. They understand linear, right? They understand linear form, they understand straight line very easily. So it's kind of like the same idea that we want to have, that we want to do. So then it's easy for us to do it in application and it's easy for us to interpret it and then to share it back with the public, with many people. So let's go through some of them. So for example, question number A, y equals ax squared plus b. So you see that the y is just the normal y, the x squared is the normal x. You know this is a quadratic relationship, right? So of course this is not linear relationship. So in this case, you can transform it into y equals mx plus c, where the y is the same y, the m is the a, the capital X is actually x squared, the b, which is the c, is actually the b. So it's just as simple as that, right? But it's not as simple as that in some cases, which we will see further later in further cases. So for example, we have question B. So whenever you look at question B, y equals ax plus b over x. So in this case, we cannot just simply say y mx c, because it will be weird for the c, not for the mx for the y, because the c must be a particular constant and it should not change. But then having it as a b over x will be weird because x is a variable. It means this guy will vary, right? Will have different values, and then c cannot change. C is a constant. So that means in this case, the y will still be the small y, right? Later on. Oh no, sorry, my bad. It's not that's not what I want to talk about. So what we need to do is that we need to omit the x first. So then we can have it without any particular variation of the value of the c. So what we can do, we omit the x by multiplying with x. So we have xy equals ax squared plus b. Then only we can say, right, that this is the capital Y, the a is the m, the x squared is the capital X, the b is the c. Okay, so I'll go with one final example. Let's say I'll do question H. Okay, let's do question H. So given is 1 over y equals a square root of x minus b over square root of x. So similar as before, what I need to do first is that I need to omit this part, okay, because that's the annoying part. So multiply with square root of x, then it will be square root of x over y equals ax minus B only. So then this guy will be the capital Y, the A is the gradient, the small x is the capital X, and then the negative B is the C. Then the thing is also that your friends or others may got different answers compared to us. So for example, there might be another idea that, sir, why don't we just omit the square root of x here instead of multiplying by square root of x? That's possible. So instead of doing that, then we can have it as, for example, let me just write it down real quick. So we divide it by square root of x. So we have 1 over y root x equals a minus b over x instead. So instead, like, this will be the mx, this will be the c, this will be the capital Y, which that also works. So it doesn't really matter like which one, as long as it's easy for us to understand as well. And of course, it does make sense to be converted. Okay, so I think that's all for this particular section. So you can try for the rest of the questions. Then you can stop this video, pause anytime that to try to make sense of this idea, and then again connect to the other video about the application. Okay, so thank you, all the best, and see you in the other video.